negative the square root of x plus 4 plus 1. So we are asked to graph using transformations, but also we will determine the x and y intercepts algebraically. So number one, I know that the base function is the square root of x. In number two, I know it's shifted. This is 4. I know it's shifted 4 to the left. So the square root of x plus 4 left 4. Now I have to address this in order of operations. So it's negative the square root of x plus 4. This transformation is on this. So this is a reflection. Reflect WRT with respect to the x-axis. Because this sign touches the outside of this function. And number 4, I have to add 1, which is up 1. Okay, before I graph, I would like to determine the x and y intercepts. I know that the graph has the domain this, because I have the square root of x plus 4. X plus 4 is under the square root, in other words, is that this is the radicand of the square root. So this has to be greater than or equal to 0, which means the domain of this function is from -4 to infinity. So I can plug in 0, and then f of 0 will be negative, so 0 plus 4 is 4, the square root of 4 is 2 with minus in front, -2 and plus 1, and this is -1. So I found 0 comma -1, the y-intercept. And now the x-intercept, I make the y equal to 0, the y variable. So negative the square root of x plus 4 plus 1 equals 0. This is from a long time ago in chapter 2. I move 1, or if you want to say subtract 1, the same thing. I multiply both sides by -1. And then I have the square root of x plus 4 equals 1. It's a square, a radical function. Let me make sure that you are muted. So okay, are we muted here? Yes, we are muted. Okay. So we square both sides to eliminate the radical, and then I have x plus 4 equals 1, and I get that x equals negative, so -4 plus 1, which will be -3. I always ask myself, is this true? And when I go back and plug it in, the square root of 1 is 1, with -1 plus 1 is 0, yes. So -3 comma 0 is the x-intercept. So I have them now. So for transformations, I have to graph the square root of x, and we all know how it looks like. Then we have to shift this graph 4 units to the left. Here it is. And this is the square root of x plus 4. Then we have to reflect this graph with respect to the x-axis. So I get this. Negative the square root of x plus 4. And now I have to shift this graph up 1. And I already have the x and y intercepts. I know this is 1, which is -3 comma 0. And I know that 0 comma -1. And this point moves up 1. So here's the final graph. So I'm going to do this so you know that this is the final graph. So this is the function f of x equals negative the square root of x plus 4 and plus 1. If I'm asked to find the range, very clearly, from -infinity till this point. So when x is -4, this is 0, so it's 1. So from -infinity to 1. This is what I would do, and this is how I would present number 12. Do we have any questions on number 12? If I don't find the x and y intercepts before I graph, then I will have to determine them and go back and adjust the graph. I find the x and y intercepts before, so I don't have to adjust the final graph. Okay, then we said number 5. Any questions on 12? Okay, on number 5. Where are you, number 5? Let's see. 7, 6, 5. Okay, so we have h of x, which is 10x minus 0.01 x squared. X is the height of the cannonball above the water when it has traveled a horizontal distance of x. Okay. So this is the idea. Right? So basically it starts when x is 0, y is 0. So it starts somewhere here. It goes up and then it hits the ground. X is the horizontal distance. So this is x. And this is the height. X horizontal distance, h is the height. How do I know it has a maximum? Of course, this is given to us intentionally like this. So we have to notice that if we don't rearrange it, we're not going to identify A, B, and C correctly. So how do I know it has a maximum? Because the leading coefficient is negative. And what is the maximum height? Of course, it's all about the vertex. Every time we talk about a maximum or a minimum for a quadratic function, that's all we are really asked to find, the vertex. So you have to remember the coordinates. You have open notes, open book, but I think by now we should remember that the x-coordinate of the vertex is negative b over 2a. Carefully, descending order, 10 divided by 2 times a, negative 0.02. It has to be a positive number, and it will be. And I multiply top and bottom by 100 because I don't want decimal numbers in a fraction, and now it's easier to identify that this is 500. And the measurement unit, don't forget measurement unit. This is feet, which this is the horizontal distance till the maximum, 500. Oops, feet. Now they're asking us to determine this. So if this is 500, how do I determine the y-coordinate of the vertex? Or, in other words, the maximum of this function? How do I get it? We have to plug in 500. So this is negative 0.01 times 500 squared plus 10 times 500. And negative 0.01, be careful how you enter everything, squared, and plus 5,000. So I got 2,500. So 2,500 feet. So this is 2,500, which means the maximum height is 2,500 feet. How far does the cannonball travel horizontally? I already have to determine that first. This is it. That's it. That was problem 5. And now let's move on to 3. Graph the function showing all. Okay, perfect. So we have f of x, which is 2x plus 6 divided by x minus 1. Of course, I notice that I can factor out 2 at the top. And I know that I have to get a table going in which I will put all my information. But first, I have to identify the type of function. What type of function is this?
Type 1?
Yes, it is type 1. Because it's type 1, I can identify the horizontal asymptote in a blink. Leading coefficient over the leading coefficient. Make sure that they are in descending order. So you can correctly identify 2 and 1. Okay, we jumped ahead because we talked about the type, but I would like us to determine the domain because we have to have it. Can anyone give us the domain of this function? Anyone?
Negative infinity to positive infinity. Negative infinity, negative 1.
A positive, right?
Positive 1.
Good.
Positive infinity.
Perfect. So it doesn't go away. We know that x equals 1 must be a VA. In that case, I will immediately write my infinities, but I don't know the sign. It will take a blink with 0.9 and 1.1. Notice that I put them up there because I'm not going to use them to graph. I'm only going to use them to find the sign. So when I plug in 0.9, this is positive, but this is negative. 0.9 minus 1 is negative. But when I plug in 1.1, positive and positive, I got the sign. When I plug in 0, these two terms go away. So I have 6 over negative 1, which is negative 6. Also, I need to find the x-intercept when y is 0. So y is 0, meaning 2x plus 6 over x minus 1 is 0. And a fraction is 0. A fraction is 0 when the top is 0. So from here, 2x plus 6 must be 0 or x equals negative 3. I put them correctly in the descending order. Let's check. Negative infinity, negative 3, 0, 1, infinity. Correct. That's all I need. Now I'm ready to graph. And the function is not symmetric. I should mention that. It's on the list, not symmetric. Why? Because f of negative x will not equal f of x, and it will not equal negative f of x. How do I know? It has a vertical asymptote at 1. It will not be symmetric with any respect to the origin or the y-axis. Not possible. But with this, I show that I know that I have to present symmetry, but there is none in this case. When we graph functions with asymptotes, what do we need to graph first? When we graph functions with asymptotes, we must graph the asymptotes first. Okay, let's do that. There are two asymptotes. Y equals 2 and x equals 1. And now all I need to do is step by step read the table. I don't care for anything else. The table tells us everything. I have to plot this point, negative 3, 0. And I have to plot this point, 0, negative 6. And I'm ready to graph. The table says, from approaching 2, cross at negative 3, 0, cross at 0, negative 6, and go towards negative infinity. One more time. Approaching 2, cross here, and get closer to negative infinity. No problem whatsoever. On the other side, My table says come from positive infinity and drop to 2. Okay. That's it. And if I want to find the range, everything, oops, and everything. So from negative infinity to 2, union 2 to infinity. Any questions? Yes, you can always check with the graphing calculator. In y equals, clear everything you have. Don't forget the calculator does not know to put in y equals 2 by itself, so I'm going to put it in y2. I'm going to put 2, and in y1, I will put, careful, parentheses. And I should always write the function. So it was 2 x plus 3 divided by x minus 1, or 2x plus 6 over x minus 1. You must put parentheses around the numerator. Parentheses 2x plus 6 divide by parentheses again x minus 1. I will use the standard viewing window for now. If I want to change, I can change. And here's the graph. As expected, and of course we know there is a vertical asymptote at x equals 1. It crosses at negative 3, 0. It crosses at 0, negative 6, going to negative infinity, and the same thing at the top. Very good questions. Anything else? Anything else?
I think someone asked for question 7.
Oh, I'm sorry, I didn't hear that. Question 7 it is. Thank you. 4, 5, 6, 7. Very good. In 7, we're given 2 functions. Let me see how I'm with time here on my video.